Hi everyone, my name is Thomas Kim. Today is 25th of August 2023. Currently it is 6:44 a.m. Open up Visual Studio Code, Electricity and Magnetism. We will create folder 166 line integrals. Click this button, line.cpp. Hit enter. Ctrl B. We can close welcome window. I will drag and drop this PDF book. This is Calculus Early Transcendentals 9th edition by James Stewart. From this book, Chapter 16 Vector Calculus, Section 16.2. Section 16.2 Line Integrals. If you scroll down, you can find example 5 in page 1137. We will solve this problem. I will arrange side by side like this. If you want to try my source code on your machine, then you probably have to watch C++ Electricity and Magnetism Vector Calculus videos in this playlist. By watching videos in this playlist, especially those videos whose title starts with setup, there are several videos that is starting with the title setup. By watching these videos, you have to install all required tools. For example, in episode 34, set up Microsoft Visual Studio, Nvidia CUDA, OpenCL C++ headers. You have to install required tools. Also note that I updated C++ library extensions. If my source code does not build on your machine, that means you are not using up-to-date C++ library extensions. Without further ado, include CPG, STD extensions. Include CPG, Calculus, namespace, CPT, CPG, types, namespace, CNA, CPG, numerical analysis, using namespace, CPG, operators and constant, using namespace, CNA, commands. I will copy and paste. We are solving example 5 from Calculus 9th edition by James Stewart. Example 5. Evaluate line integral y sin z ds along curve C, where C is the circular helix given by the equations x equals cosine t, y equals sine t, z equals t, t is greater than or equal to 0, less than or equal to 2 pi. See figure 9. In figure 9, there is a helix. For the solve example 5. Int main std cout precision 12 std cout std bool alpha. Copy this function name and paste it in the function main. Here cpg display function name. If you want to try my source code on your machine, you have to create such command prompt. This is for Intel oneAPI Toolkit. This is for GNU G++ and Clang compiler. This is for Nvidia NVCC CUDA compiler. You have to create such command prompt. We will try with the GNU and Clang compiler first. CD 166 line integrals Clang++ version. I'm using Clang version 16.0.5. C++ version. I'm currently using GNU G++ version 13.2. dir Clang++ std C++20 line.gpp. We need switch ltbb 12 or c.exe. Hit enter. clsc. You will see this message from function void solve example 5. This message comes from this line of code. I will copy this command string for your convenience here. If you are using GNU G++ compiler, then you can use G++. It can be G. Now we have to define integrand. I will make it bigger. See, this is the integrand. Y sin z is the integrand. Or int g, or x, or y, or z. Don't miss semicolon. Return y times SED sin z. Now we have to define parametric equations for our curve C, this helix. Luckily, we have parametric equations here. CNA BCTR3D. I will denote parametric equation with uppercase R. This is vector. I use curly brace, semicolon, or T, return SED cosine T, comma. We defined x equals cosine T. We can say MIT x equals cosine MIT T. Ctrl-Alt-Q. Now copy, paste. This is sin T. MIT y equals sin MIT T. Ctrl-Alt-Q. Now copy, paste. This is T. We can remove trailing comma. MIT Z equals MIT T. Ctrl-Alt-Q. So this vector R parameterize x equals cosine T, y equals sin T, z equals T, or this curve this curve is represented with a position vector r. Now, for helix, we use this parametric position vector r, line integral. This is a function. We provide int g. This is our integrand. This int g represent y sin z, y sin z. Then the limits of t runs from 0 to 2 pi. So 0.02 times pi. Now our answer square root 2 times pi. This answer comes from here. SED, CL, answer, CPG, and copy, paste, helix, copy, paste, helix here. Now I will remove blank space. We will be using GNU compiler. G, hit enter. CLS G. So the numerical solution is accurate up to 11 decimal places. Now I will explain this formula. Please notice we are in page 1135. Equation 8. This equation deserves to be committed to your memory. When we are setting up a line integral, sometimes the most difficult thing is to think of a parametric representation for a curve whose geometric description is given. In particular, we often need to parameterize a line segment, so it is useful to remember that a vector representation of the line segment that starts at R0 and ends at R1 is given by equation 8. It is useful to remember that a vector representation of the line segment, this formula should be memorized. Please notice this formula can also be represented like this. Void test vector representation of line segment. CPG display function name. Copy this function name, copy, Ctrl N. Paste it here. Now I will make it bigger. Scroll down. We are in page 1138. This is curve C2. CNA, BC, TR, 3D, R0, 3, 4, 5, 3.0, 4.0, 5.0. Copy, paste. This is R1, 3, 4, 0, 3, 4, 0. Please notice this curve 2 is directed with this arrow. This is starting point or initial point. This is terminal point. This curve 2 is directed with arrow. R0 is initial point or position. R1 is terminal point or position. We can use this formula here. CNA VCTR 3D C semicolon. We capture A by subtracting R1 MX R0 MX. Then B R0 MX. I will make it bigger. Or T return A times T plus B, comma. Please notice R1, R0. This VCTR3D has member MX, so we subtract two vector R1, R0. We subtract R0 from vector R1. This is X component. B represent X component of R0. I missed semicolon. Copy, paste. Now MY, now MG, remove trailing comma. So this C represent curve C2. I used this formula. This formula is equivalent to this formula. SED, Cout, R0, CPG, and there. Copy, paste. This is R1, Copy, paste. I will change it to and there. Now C0, C0, C1, C1. I will remove trailing lines. This does not build. Notice the squiggle. We have to use floating point number. We cannot use integral numbers. We can't. We always have to use floating point number. With this, I'll be using Intel Compiler, line integrals, SYCL version. I'm using Intel Compiler 2023.2, SYCL QSED C++ 20. Don't miss EHSC FNO SYCL line.cpp or i.exe, hit enter. I'm using Intel compiler, CLSI. Please notice C0, R0 identical. C1, this is C1, R1, this is R1, they are identical. So, in this parameterization, when t is 0, we have R0, initial position or point. When t is 1, this t, the parameter is t. This t is 1, we have position R1 or terminal position. When the parameter t is 0, R0, we have R0, initial position. This formula should be memorized. Now scroll down. We implemented this part. I will disable it. Instead, auto CNA parameterize line segment. We provide R0, the initial point, R1, the terminal point. We rebuild CLSI. The result is identical. I will copy this command string here. Now scroll down. I will make it bigger and zoom out. Example 6. Evaluate line integral y dx plus g dy plus x dz over curve C, where C consists of the line segment C1 followed by the vertical line segment C2. We have figure 10. C1 is directed from the initial position 2, 0, 0 to the final position 3, 4, 5. Then C2 from 3, 4, 5 to 3, 4, 0. I will copy and paste for the solve. Example 6. Method 1. Copy this function name, paste it here. I will disable this part. Now CPG display function name. Auto C1 CNA parameterized line segment semicolon CNA BC TR 3D 2.0 copy paste 3.0 4.0 5.0 remove trailing comma. So this is the initial point. This is the terminal point. We can omit 0, 0. When y and z components are 0, we can omit. I will copy and paste. This is C2. Cut, paste, paste. Delete this. We can omit the z component. This is curve C2 from 3, 4, 5 to 3, 4. Now we define the integrand y, z, x like this. CNA, BC, TR, 3D, I would say F semicolon. Please understand, we need 3 parameters for x, y, z, or x, or y, or z. We need 3 parameters. This represents x component. Return y. MITx component. Copy, paste. This z represents y component. Z. MIT y component. Ctrl Alt Q. Copy, paste. This x represents z component. It should be x. Remove trailing comma. MITz component. Ctrl Alt Q. So this is x component. The integrand of x component is y. So this is y. This represents y component. The integrand of y component is z. So this is z. This represents z component. The integrand of z component is x. So it is x. We defined using VCTR3D. In this case, each member takes 3 parameters. Now, we will perform integration along the curve C1. I will use lowercase letter C1. C1 line integral. We provide f from 00, 10 because our parameterization assumes t 0 less equal 1. We assumed t runs from 0 up to 1. As I explained here, don't forget this. When t is 0, this is R0. When t is 1, this is R1. Don't forget this fact. Now, copy, paste. This is C2. C2. We are performing line integral over curve C2. This part. Then we can say or C, C1 plus C2. This part corresponds to this part. SED, Cout, C1, C1, CPG, and copy, paste, C2, C2, C. I will remove blank lines. With this, I'll be using Microsoft Compiler, CL, SED, C++20, line.cpp, don't miss, EHSC, FEM.exe, hit enter, CLSM. So C1 is 24.5. This is C1. This is C2. C2 is -15. -15. C is 9.5. 9.5. I will copy the command string, copy, and paste it here. Now scroll down. This is solve example 6, method 1. In this method, we used VCTR3D. Each member of this vector takes 3 parameters. There is another way. I will copy, paste it here. Now this is method 2. Copy, Ctrl N, paste it here. Scroll up. This part is the same. I will delete it. CNA VCTR 3D F1 semicolon. I will capture Y from C1 FY or T, return YT. Copy, paste. We capture Z from C1 FZ, then Z. This is X, X. Now copy, paste. This is F2, C2, then F1, F2. Please notice, in this case, we capture Y component of curve C1 because in this integrand, we need Y for dx. In this case, we capture Z component of C1 because we need Z for this part of line integral. In this case, we capture X component of C1 because we need X for dz. In case of F2, we capture from curve C2. With this, we can use any compiler. CD 166 line integrals. Now we are using CUDA compiler NVCC SCD C++20 line.cpp or n.exe. Hit enter. CLSN. So method 2 gives the same result. I will copy the command string, Ctrl Home, paste it here. I will put download link of this source code in the description section below this video.